What did Earth look like 250 million years ago? This is your hypothesis. The mechanisms for how tectonic plates move are mantle convection. So that's where the hot stuff goes up, it's less dense. The cold stuff goes down, it's more dense. And as it moves, the plate on top will just kind of ride on top of the mantle. Slab pull, if this big hunk of rock gets pulled down into the mantle, it kind of drags the whole thing with it as it gets down there and melted. And ridge push, where as the mantle is pushing up, the magma is pushing up, it's going to cause a ridge, which is going to shove this plate one way and this plate the other way. So we know the directions the plates are moving today. And feel free to look at this map, get an idea of which way they're moving. So if we know which way they're moving today, you could kind of figure out where they used to be based on how fast they're moving today. If the African plate is kind of moving to the east and to the north, and then you can kind of figure out, then it must have been from the south and the west. If the South American plate is currently moving to the west, it must have come from the east. So you can do this with all of the different plates. So we also have fossils around the world. I'm going to focus right here. This one's Mesosaurus. So Mesosaurus is found in South America, but it's also found in southern part of Africa. Mesosaurus was a marine animal, but it couldn't have swum all the way across the ocean. There are some other animals. This one right here, Lystrosaurus, found in Antarctica, also found in Africa. And then you've got this one, Labyrinthodont, found in Australia, southern part of Africa, also found in Antarctica. So how is it possible that these animals, and then you've got Glossopteris, this plant found in South America, Africa, India, Australia, and Antarctica. So how is it possible that these things were found completely separated from each other? Similar rock types found around the world. So the rocks in South America and the rocks in Africa, India, Madagascar, Australia, and Antarctica all have the similar ages and similar compositions. In other words, they're essentially the same rock. So how is it possible that these rocks have gotten all the way across the oceans from each other? So these are the current climate regions around the world. You'll notice that areas that are close to the equator are pretty warm and wet, called tropical zone. Then as you get a little farther away, they get a little drier and a little cooler. And then as you get much farther away up near the poles, they're much drier and much colder. However, based on fossil records, these are the climates from roughly 200 or 300 million years ago. That the central-ish part of South America and the southern part of Africa were actually much more mild. North America and Europe were a lot hotter, as was Greenland. And then obviously Antarctica and Australia were very cold. But Antarctica was not as cold as it is today. So the evidence of glaciers or ice is left behind in South America, Africa, India, Madagascar, Australia, and obviously Antarctica. So again, how is it possible that we have a place like India, which is very warm, and Australia, also very warm, Africa, very warm, and even a little bit farther north in South America, how is it possible that these places that are very, very warm today have leftover marks from glaciers? So based on your observations, what can you conclude about what the Earth looked like 250 million years ago? Take some time to draw a picture or a diagram and discuss and write an explanation of what Earth looked like based on your observations. This would be called your conclusion. Now that you have discussed and written some ideas about your conclusion, get up, move around, stretch, grab something to eat, watch this 4-minute video about Alfred Wegener's theory, and think about the questions during the video. So the video is right here. You do have to, it doesn't automatically play. And then these are the questions right here. Think about those while you're watching.